Alright guys, in our last section we created this class-based component and understood each of the lifecycle methods one by one. Now in this part we are going to create a function component and see how we can use the newly introduced React hooks inside our function component. So we are gonna redo this entirely in this class-based component into a React function component. So the way it works is that, as we did it in our previous, I think the second part, we created function component by simply writing a function which accept the props like this. And let me add a default export. So this function component needs to return whatever we were returning from the render method of our class-based function. So for example, h2 and props dot greeting, and now there's no constructor. Why? Because this is a function and you can't a constructor belongs to a class and not to a function. So the purpose of using a constructor in the app class component was to initialize some state variables. So the way we initialize state inside the function component is by using one of the hook called as the useState hook. So that's the first hook that we are going to use, which is present inside this React export. It's called useState. So the naming convention of all the hooks, they start with the use keyword and then the hook name. And so for example, we want to create a hook, create a state hook whose value starts with 0. Initial value we have to pass, and this in turn returns us a pair, an array of 2 elements. The first element is that we represent the current value of that state variable that we want, and the second value is the function that can be used to update that state variable. So for example, we can name it as setCounter. So this is how the naming convention works. You provide the name and then you write set and the name of that variable. So for example, here we can write simply, also there's no this keyword inside these function components because these aren't class-based objects. So here we have this hello from index and 0 is being rendered here. So now let's implement the timer thing that we implemented in our class-based function. So we have to get tabbed into the component did mount hook lifecycle method. So the way we do that in our function component is by using the UseEffect hook, which is a very important one and we'll be using it very frequently. So if you notice carefully from the class-based component we had earlier, component lifecycle methods, they were component did mount, component will unmount, and component did update. These were the 3 methods where all the side effects were allowed, which means that we could make an API call inside those methods, right? So UseEffect is one of the hook or a way inside function components in React wherein we can tell React to perform some side effect. The most prominent of them being making an API call, or setting up the timer, or making any changes to your state in response to something. So this is how a UseEffect hook looks like. It accepts a callback function inside which we can perform a side effect, and as a second argument it accepts an array of dependencies, as it's called. So what dependencies means, we'll see that in a moment, but if you leave this dependencies array as a blank array, it'll simulate the behavior of a component did mount. Okay, so this is how a component did mount looks like, which means this will get called whenever the component gets mounted for the first time. So here we want to initialize our timer set interval, and same way we will increment our counter every time, and the setCounter method can either accept a straight away of some value, or it can accept a callback function, something like a previous counter, like this, and you can increment it by 1 every 1 second. So yep, our counter updation logic is set inside our component mount hook, which is represented by UseEffect with blank dependencies as its second parameter. So if we notice carefully here, it should start our counter, and it's updating very well. So you see how we reduce a lot of boilerplate code, unnecessary code, by simply writing a function component and using this UseEffect hook. Now consider the situation wherein we might want to listen to one change. We want to simulate now the component did update, wherein we are checking when the one of the properties or one of the state variable of that component got updated. So it's very easy with hooks. So again, you have to use the UseEffect hook, which means, so we are listening to one of the property change or one of the state change with an intention to make a side effect, as did it in our last case, wherein we listened to a change in the user ID prop and we made an API call pertaining to the new user ID call, and we had to do all that comparison by ourselves. But here in the UseEffect hook, if you pass anything as a dependency in the second array, it will be evaluated for any changes, and only when the variable value gets changed, either of the value gets changed. For example, I want to do something when the counter variable changes, counter state variable changes, or maybe suppose when the props.greeting greeting value changes. So if either of these variables value change over time, this callback will be executed, whatever we are going to write in this. So for example, let's put a console log, and by the way, console log is also a side effect. Why? Because it is an IO operation. We are outputting on our console directly. So let's see. So you see, right now, since the counter variable is getting changed, we are getting this output. This function is being getting executed, this side effect. And so we don't necessarily need to pass, so we can limit our dependencies to the focus variable that we want, so that we can react to the changes on only those variables that we are concerned with. So for example, if I just want to listen to counter, I'll simply list counter here, and if I want to perform a side effect pertaining to a change or reacting to a change in the greetings prop, let's say, I'll write another UseEffect here and pass props.greeting here, and maybe perform something relevant to greeting. Okay, so this is how we are simulating our component did update method, as we saw in the class-based functions, class-based React components. So that's about it. And the way we can simulate our component will unmount is by simply returning a callback function from here. And remember what we did last time. So we want to clear our interval, so we can do something like this: clear interval and timeout. So this behaves the same way as component will unmount as in our class component. So when the component unmounts, this will get called, and it will clear our time there, free and also free our memory resources. So that's about the use state and use effect hook. Now let's look at a few more hooks which are very useful, and those are UseMemo. So a UseMemo hook is very useful when we want to memoize the result of some computation. So for example, we had this requirement of this shout greeting. We were getting the greeting prop from the parent component, and we want to transform it in some way before we use it in our component. So same way we can create a variable here in a very clean manner. For example, shout greeting, and I can apply this props.greeting dot to uppercase, right? And instead of using props.greeting here, I'll simply pass shout greeting here, and it will reflect the updated version, the transformed version. Now this is a very minor transformation. Now assume I had to perform very computation intensive task, right? Maybe I was given a list of array, like 100 array, and I had to perform some mapping and filtering and reducing on top of it to get something rendered in my component. So assuming this is a very computation intensive operation, that's where we can use the UseMemo hook. Now UseMemo memoizes the result of that computation, and only when the dependencies change, it will recompute that variable. So for example, this component gets for example, this app component gets rendered a lot because of the set counter state variable change, right? And we don't want to recompute our shout greeting every time that state variable change, because it's not relevant to that, right? The computation is going to give the same result every time. Doesn't matter the set counter gets executed 100 times or even 200 times. So we want to only change the output of shout greeting only when the prop of greeting that's passed to it changes, right? So this UseMemo basically memoizes the result of that computation for that particular input, and only when the input changes, we update our shout greeting. So now we have the result is the same. We have just optimized our performance here. So that's about the UseMemo hook. The next hook that we are going to talk about is UseCallback hook. So just like UseMemo is used to memoize values, same way UseCallback hook is used to handle, let's say click, used to memoize the functions themselves. So this is very useful wherein you don't want the function references to be changed every time. So for example, if I declare a function here, let's say function foo, and since whenever set counter gets executed, this whole function body will execute again, which means that every time a new reference of this function will be there, and which means that if I have, let's say, a to-do component here, and it accepts an on-click event, and I pass it a foo function. Now it'll mean that on every render, a new reference of the foo function will get created, and it'll get passed down to the another component, which will result in its rendering, and that will be an unnecessary re-render because we clearly don't want our function reference to get changed. So this is where the UseCallback hook can come handy, and it'll look like this: handle click. Let's name it something, and we'll use the UseCallback hook. See, any hook, UseEffect, UseMemo, UseCallback, they accept the first argument, and the second argument is the dependencies, which will be used to determine when the value on the left hand side would change. So inside the UseCallback function, we can write a function body, whatever we want to happen when the on click gets executed. So let's say we want to do this, and so this is just a performance optimization technique, and this is how we use it. When we'll use it in our practical example, we'll get to understand more, but right now let's just simply see how we are going to use it. And so this handle click function reference will stay the same across several re-renders of this app component, no matter what, and only when some of the dependencies that we have passed to it would change, only then it will be changing. And since we are passing it a blank array here, This means that it'll be only defined once. Handle click will always hold one single reference that that it got during the first definition. It won't get changed over time, right? So for example, if I do this counter, now it'll behave the same way as earlier. That it's the same as not even using a use callback in the first place, because counter is getting updated every time on every render, and in the same manner handle click will also keep on getting new references. So that's about the use callback, UseMemo, and UseEffect hooks. There exists one more hook called as useref. Now sometimes we want to get hold of the DOM elements inside our component to get hold of their attributes, or change them programmatically or something. So for example, I want to gain a reference of this S2 component, and the way we can do this is by initializing, let's say, holder ref equals to use ref, and we can do something like ref holder ref. So this ref attribute accepts a ref method, ref construct, and and here, for example, inside any of these effects we can access holder ref here. So for example, console.log holder ref will now hold the value of this DOM element. So if we see this here, so by the way, these ref variables have this property called as current, which holds in turn the DOM element like this. Now if we see, so we are having a hold of this h2 element, so which means that I can programmatically mutate it, mutate some of the, let's say, dot style dot border equals to 2 pixels solid black. So when the component gets mounted, I want to programmatically change the border of the wrapping element to black. So that's how I'm able to do it, right? So if you see here as well in the inspect element, you'll see the style of border has been added. So this is the way you can get hold of the DOM elements programmatically in JSX very easily. In the earlier versions of React, this was a little difficult and verbose, but through the introduction of these very handy hooks, it has become very neat and concise. Also, there are some rules of hooks, of using React hooks. One of them is that you can't conditionally apply a hook. For example, you can't wrap this use state or use ref hook or a use effect hook inside an if statement. It can't be nested inside any other conditional JavaScript construct. Also, you can only use hooks inside the functions which are meant to be used as components. So for example, I have this app function which I'm going to be using like this. But if you have any other general purpose function, you shouldn't be using these hooks inside them, because that won't make any sense. Thanks for watching, guys. In the next part, using the knowledge we have gained so far, we'll be creating a real world example using the GitHub API, so stay tuned. Thanks.